Hello everyone, welcome back to DataCraft, your go-to place for all data engineering things. If you're new here, don't forget to hit that subscribe button and click the bell icon to stay updated with our latest videos. So today, we will be exploring various advanced SQL techniques that are crucial for data engineers. These techniques will help you to manage and manipulate large data sets efficiently. Let's dive in. Advanced SQL techniques are essential for data engineers to handle complex data transformations, optimize performance, and ensure data integrity. In this presentation, we will cover several key techniques including common table expressions, which is usually called CTEs, Windows functions, pivot and unpivot operations, dynamic SQL, and error handling with try and catch. These techniques go beyond basic querying and are vital for effective data engineering. For this demonstration, I will be using AdventureWorks database used previously on SQL Basics for Data Engineers. So moving on to Azure Data Studio, I have just opened the T-SQL script with set of queries for this demonstration. The CTEs or common table expressions are used to simplify complex queries by breaking them into manageable parts. They allow you to define a temporary result set that can be referenced within a select, insert, update, or delete statement. Let's take an example of a sales order ID 43659 and let's see what's there in sales order details table and sales order header table. It looks like in sales order details for this particular order ID we have 12 records, which are basically the line items or sales happened or product that's been purchased for this particular sales order ID. And we could see its unit price and the line total. And while in terms of sales order header, we have a single record for the sales order ID with its order date, due date, and shipment date with its status and sales order number and purchase order number. What if a business wants to compute the total sales amount of the sales order ID along with its order date, shipment date, and due date? For this scenario, we can make use of CTEs where we have created a sales order detail CTE that basically computes the sum of line totals to compute the total sales amount for each of the sales order ID. And later, this CTE is joined with sales order header on sales order ID to compute for each sales order ID what is the total sales amount and its order date, shipment date, along with the due dates. Next, moving on to Windows functions are the powerful tools for performing calculation across a set of table rows related to the current row. They allow you to compute values like running totals, ranking, moving averages, like that. Let's have a look at a customer ID 11000 under a sales order header table. It looks like this particular customer is having 3 sales orders. What if a business wants to know the running cost over the time period for this customer? Then we can use Windows function. The over clause defines the window of rows to which the sum function is applied, partitioned by customer ID and ordered by order date to compute the running total, which we can see here, where this particular query tries to compute the running total over the different order dates for this particular customer. Moving on to pivot operations, they are used to transform rows into columns and allowing you to summarize data in a more readable format. For this example, I will use 3 tables, and this 3 statement retrieves all the columns from department, employee, and employee department history tables in human resource schema. And just have a look what's there in those tables. What if business wants to understand the number of employees hired in each department for the year 2009, 10, and 11, for which we can use the pivot query something like this. The inner query joins the employee table E with employee department history table EDH on business entity ID column. It selects the department ID, the year of hire date, and the business entity ID. Later, moving on to the pivot clause, transforms the data from the inner query. It counts the number of business entity ID entries for each hire year, that is 2009, 10, and 11, and arranges them into columns. The result is a table with department ID as a row and the years 2009, 10, 11 as column, showing the count of employees hired in each year. This final selection retrieves the department ID, the counts of employee hired in 2009, 10, 11 from the pivoted table. So moving on to unpivot operation, which is a direct opposite to pivot operation, or used to transform columns into rows, which is useful for normalizing data. We'll be using the result set of previous pivot operation that has years in column, that is 2009, 10 and 11 in columns with its employee counts for against each department ID. And we basically need to transform or unpivot to return a normalized format with higher years and employee count as rows. We are unpivoting it and trying to run the query. Now we could see those columns are converted into rows. Moving on to Dynamic SQL, they allow you to construct and execute SQL queries dynamically based on variable inputs. This is useful for scenarios where the query structure needs to change at runtime. In this example, we dynamically set the columns to be selected and construct the SQL query accordingly, and then the SP execute SQL procedure executes the constructed SQL query. So here we have defined the variable columns and SQL, where we have defined for columns like what columns we need to select, and in SQL we define the structure of our SQL statement that needs to be executed, and we have passed the variable inside this. And when we are running the script, we could see like it selects the column we need and it returns all the records. And what if we need to filter for a particular product name like LL Folk? So for this, like, we need to define a variable and we have to set the variable filters we need to pass, and we have to construct the SQL query for this, and we have to run it. And we could see now the filter records it shows here. Moving on to error handling, they are the crucial for robust SQL scripts. The try and catch construct allows you to handle error gracefully within your SQL code. In this example, we intentionally generate a divide by zero error within the try block. The catch block captures the error and returns the error number and message, which allows us to handle it appropriately. To conclude, we covered several advanced SQL techniques that are essential for data engineering. These techniques include CTEs, window functions, pivot and unpivot operation, dynamic SQL, and error handling with try-catch. Mastering these skills will enable you to handle complex data transformations, optimize performance, and ensure data integrity in your projects. If you found this video helpful, give it a thumbs up and share it with your friends. And don't forget to subscribe for more content like this. Thanks for watching, and I will see you in the next video.